Make sure your calculator is in degrees. Some of them have like a DRG button on them. Most of them, when you turn them on, you know you're in degrees because they'll have like a little DEG or a little D under it. If you don't know how to turn it into degrees, then you're just going to have to let me know and I can help you figure out how to do it. But here's the big tester to know if you're in degrees or not if you can't tell. If you plug in your calculator, the sign of, let me pause this because I'm not writing. Plug in the sign of 30 degrees, you should end up with 0.5 or a half, depending on your calculator. Sine of 30 degrees, you get 0.5 or a half. Okay, good. If you get that, then you know you're in the right spot and we're ready to cruise. So in the past, like I said at the beginning of class, this is going to look more like the trig that you've done in geometry and in previous classes in Algebra 2, where you used like SOHCAHTOA and found the sine and the cosine of things, and you used Pythagorean theorem. Except for we're not going to be able to use either SOHCAHTOA or Pythagorean theorem because those are reserved for right triangles only. And so we're going to be solving triangles or working with solving triangles where where it's not a right triangle. Okay, so let's draw our picture, and I always kind of draw the same old dummy picture of my triangle. No matter what the angle measures are or anything, I just sort of draw this same picture just for the sake of having letters that I can label and angles that I can put in and sides. And so if I call this triangle ABC, the vertices or the corners are all labeled capital letters, and those represent the angles. And then across from each angle is its lowercase counterpart, and those represent the sides. So across from capital A, angle A is side A. Across from angle B is side B. Across from angle C is side C. Okay? And again, these are not right triangles. So when we're working with our solving today, Pythagorean theorem and SOHCAHTOA are not an option. We're going to be using something called the law of sines and the law of cosines. Now I'm starting out with the law of sines first because it's the easier of the two. It's kind of the less work of the two. What happens when, or the law of sines looks like this. The sine of an angle over its opposite side forms a ratio, and that ratio of angle to side, sine of angle to side, is equivalent all the way around to all the other angle to side ratios. So the sine of A over A is going to be equivalent to the sine of B over B, and the sine of B over B is equivalent to the sine of C over C. And the last one, the sine of A over A, is going to be equivalent to the sine of C over C. So it's every combination of side. You could set up something we call a proportion. Proportions you did back in middle school. You probably started those in maybe 5th or 6th grade. Do you remember working on cross products where you would have like 7 over 8 equals x over 10, and you had to find x, and so you'd cross multiply. 7 times 10 equals 8 times x, and so you could solve 70 eighths is x, kind of go through, cross multiply and divide. We're going to be doing that same cross product concept, except for we're going to be using the sign in our equations as we work through. And so the biggest issue that people have in this chapter is calculator error, like personal, like plugging something in wrong. So I'm going to talk about the things that you have to make sure that you do as we go through this, kind of more than the math part of it, because we can all kind of plug stuff in. It's just making sure we do it right. All right? So let's start moving. First thing I'm going to do for these problems is draw my triangle. And again, I said I start off with the law of sines because I think the law of sines is easier than the law of cosines. And when you set up your triangle, label your angles, and you're going to, or label your parts, label your corners, your vertices, HPK, this one's called. So I'll call angle H 61 degrees, angle P 99 degrees. Side H is across from angle H 23 kilometers, and across from side P is, or angle P is side P, and that's the one I'm looking for. That's my unknown. You can use law of sines anytime you have a triangle that allows you to set up a proportion where there is only one variable. And so I can set up a proportion by putting the sine of H over side H, so the sine of 61 over 23, and the sine of P over side P, so the sine of 99 over P. Notice I have only one variable to use. And if I am able to set it up in that way and I have only one variable, then I can just do my cross products and solve. So this is where using your calculator you have to be a little bit careful. I multiply the two diagonals, and then I hit equals, and then I divide by the missing part. Or you can just plug it in your calculator. So I could plug in 23 times the sine of 99. What you have to be careful of is your calculator, when you plug in the sine of 99, will automatically like open a parenthesis. You have to make sure you close it. And that's what I was talking about earlier, like the little details that we have to make sure we do right. Because if you forget to close it, it's going to take the sine of everything you put after it, and you'll end up with a funny answer. Okay? So I close that, and then I'll divide by the sine of 61, and I can hit equals, and I'm going to get the value of P. The directions said round to the nearest tenth. So I'll get an approximate P. A squiggly equal sign is what I put to represent approximate P. But what do we end up with on that one? .26, yeah, so it's 25.9 something, right? So we do 26.0. You don't have to put the .0 on it, but I'm just showing that I'm rounding to the nearest tenth. That would up it to the nearest tenths. So 26 kilometers is what we get. So the math here is not so bad, especially if you're finding a side. The sides are kind of easier to work with than finding the angles. So the next one is finding a missing side as well. And I'm going to have you guys try and set it up and solve, see if you can kind of go through that process, and then we'll revisit in just a moment. Okay, so our goal is to end up with that 17.0. Again, you don't need the .0 on there. That's just the rounding, and then put your miles on in the end. So the last two on this page with the law of sines are going to be finding the angle, and that's where we're going to have to use that inverse sine. Do you guys remember that? Most of our calculators, we have to do like the second sign. It's the little writing above. Some of you have it different, depends on the calculator. I think on the graphing calculators, you'll find it under the trig mechanism. It'll have it there. If you're using your phone, it might be something different, so you're just going to have to kind of play around with what you have. But you're looking for, again, the sine inverse key. It's that sign with the little -1. And you use that when you're getting back to an angle. So anytime you're going to find an angle, you're going to have to use an inverse trig function. In this case, we're going to use inverse sine because this is the law of sines. When we do the law of cosines, we'll have to do an inverse cosine to get back to an angle. But I'm going to start the same way. I'm going to draw my picture the same way. So this is y, z, and x. I label everything. And don't get too worried about like what your things look like. If this is, I'm not sure if that's a really 75-degree angle. It doesn't really matter. We don't care that much about size. You know, even in the problem above, that looks like it's more than 54 degrees. That's not the point of drawing the picture. The point of drawing the picture is just so you have a place to hold things, okay? So fill that in. Side X is 25 and side Y is 33, and I have to find angle X, so I'm finding that bottom in my picture. It's the bottom left angle. So I'll set it up the same way. I can use law of sines every time I can set up a proportion, in which I have only one variable. And so I will do the sine of 75 over its opposite is equal to the sine of x over its opposite side, which is 25. And I'll even do this next solving part the same way. I'm going to cross multiply. So I'll do 25 times the sine of 75. Don't forget when you plug in the sine of 75 to close your parentheses. And I'll divide it by the side that's left, or the number that doesn't have the variable in it. And when I do this, I will get the sine of x. That's what the sine of x is going to equal. But it's not what x equals, it's what the sine of x equals. So there's another key on our calculator that we're going to use. It's called the answer key. On my calculator, it's above the negative sign. And I think that's where it is on most calculators. But it's just ANS. So before we use that answer key, let's plug this in. I get 25 times the sine of 75. I close my parentheses. I divide by 33. I hit equals, and I get some decimal. This decimal for me looks like 0.73176, blah, blah, blah. Does that look like what you guys got? Okay, good. That's what sine of x is, but I don't want the sine of x. I want the inverse sign. So don't round. Don't plug in only some of the numbers. Just hit the sine inverse. Make that show up on your screen. Sine inverse, however you do it, second sine, or if you have to go into the trig mechanisms, make that show up on your screen. And then hit the answer key. And it will show ANS. It'll bring all of that stuff down into the calculator for you so you don't have to write it down and rewrite it. Some people who were using their phone earlier had to cut and paste that to use their phone to do that, but most calculators, like I said, have the answer key. So I do second sine, second answer, second negative thing is for me, and then I hit equals, and I should get my value for x, which is roughly 47. Again, it said round to the tenths, 0.0 degrees. And again, you don't need the 0.0, but I'm just going with what it said, round to the 10th, so I put that there. Are you guys okay with that answer thing? Does that kind of make sense? Okay, so the next one is the same. Again, let's set it up and see if you can go through the problem. I'm going to do the work, and then you will take a look and see how you did when we're all done, okay? So hopefully you end up with the 18.0 degrees. Again, 18 degrees is fine if you write that. Like I said a couple times already, you can use law of sines anytime you can set up that proportion when you're solving a triangle. Anytime you can set up that proportion where you have the opposite or are able to set up a proportion where there's only one variable in it, law of sines can work. But that's not always going to be the case. You're not always going to be able to set up using law of sines. In fact, there are going to be instances where you set it up and you have two variables. And so I'm going to go down to the first example on this law of cosines page before we introduce the law of cosines. I'm going to draw this triangle. Don't write down what I'm going to write down after I draw my triangle. You can start by drawing your triangle, but don't write down what I'm going to write down because I'm going to erase it anyways. But I just want to show you what I'm talking about, like how do you know if you can use it or not. So when I draw this CAB, then across from B is 28, across from A is 21, and angle C is 103. I need to find side C. Well, if I do sine of A over A and the sine of C over C, I have two variables. If I replace this with the sine of B over B and the sine of C over C, I still have two variables. And so the law of sines, try as I might, is just not going to work for this problem. And so I have to resort to a different method, and that's the law of cosines. When you're solving, I always start with the law of sines. I try the law of sines first because it's easier. The law of cosines is a little bit more complicated formula, and it leaves more room for error because it's a little bit more complicated. So if you can do law of sines, do it. If you can't, then this is your last ditch effort. So we'll have the same sort of triangle, A, B, C. Across from A is side A, across from B is side B, across from C is side C. That's a B. I don't know why I left so much room here and not a lot of room to work. I apologize in advance for that, especially when we get down to the last problem. You're going to be like, I can't fit it. So, sorry. But the law of cosines looks like this. A squared is equal to B squared plus C squared minus 2BC cosine A. I've got actually two more of those to go through. But going through them, as you're going to find as we kind of work through this, it's not necessary to know all the different combinations of the letters. It's just to know where things go. And so the thing you want to watch out for when you're doing law of cosines is that the side that either you're looking for or maybe you have has to be across from its opposite angle. So when you put that in, because A squared is on the left-hand side, I have to be looking at angle A. Looking at or looking for angle A, okay? And so I could set this up with B squared as well, but then I'm going to have the cosine of B on the end. Does that kind of make sense? If it were H, it would have to be H squared, and its angle would be the cosine thing. So they're going to be furthest apart. And then as far as whatever letters are left or whatever sides are left, the order that you put those in doesn't really matter. So I could do A squared plus C squared minus 2AC, or I could do C squared plus A squared minus 2CA. That part doesn't make a difference, but that's a C. And so then the last variation of this would be C squared is A squared plus B squared. A squared plus B squared minus 2AB cosine of C, and that's a B. So let's go back down to that picture that we kind of drew in already, and we can go ahead and set it up. I'm looking for side C, so C squared is what's going to go on that far left-hand side. And that means cosine C has to be the far opposite side. And for some of us, this is kind of obvious when it's written or set up in a certain way, but other times, like when I'm looking for, when I have three sides given, then it might not be as obvious what goes where. So we have to put a little bit more thought into it. So C squared, and then the other sides, again, they don't really matter the order that you do them. I just have to do the one side squared plus the other side squared minus 2 times those two numbers. I'm going to erase that and rewrite it so I get it in better. So 21 times 28 times the cosine of the 103. Okay. I highly recommend, once you get it set up, like I said, it's a more complicated equation, but once you get it set up, I highly recommend you just plug it all in your calculator. Don't try to do pieces, because when we try to do pieces, break it into smaller parts, sometimes we miss the order of operations. And if I'm working through this problem, the order of operations would have me multiply all of those things on the end together first, get that answer, and then do the addition and subtraction from there. But you can avoid having to think about that by just, again, taking your calculator and plugging it all in. All right, so when I plug it all in, I got 1489.5424, blah, blah, blah. Again, depending on your calculator, it might give you more or less decimals. This is where that answer key comes in handy again, because this is c squared and I need to find c. So I can just do the square root. I just do second square root, second answer, and then I'll get my c value. So remember, you have to take the square root of both sides. So c I got to be 38.6. And that is kilometers. So don't forget to do your square root of that. Yes. So if you got 39, it's probably because you just put in part of here, put in an estimated or approximated rounded one. I don't recommend that, because as we cruise on further, it's going to affect your answer. So keep it as long, or as much as you can, as much accuracy as you can, as long as you can. Okay, so that's like why I said, if you do the square root of the answer, bring that answer down, you won't have to remember anything or plug anything in. Was I right in that? Is that what you did? Yeah. Okay. So, and then to answer your question, I will keep that in mind when I'm correcting. If, like if people round a little bit differently, or sometimes people do a problem where they could use either the law of sines or law of cosines, and sometimes you get a little bit different answer for those as well. I keep that in mind, but my recommendation is try to keep it as exact as you can, as long as you can. Okay. Okay, so problem number 6, again, is just like number 5, and I'm going to have you guys run through that one on your own as well, and then we'll revisit when we're done. So give it a try, see what happens, and then we revisit, and then we'll move on to finding the angle, which is a little bit different. Okay, so again, your goal should be to get that 12.0 feet, or just 12 feet. And so far with the law of cosines, we've just been solving for the side. And like I said, you can just plug that all in your calculator. In fact, I recommend plugging it all in your calculator. The biggest error that I have people find is that they look and they didn't get this exact answer, and then they look back and they're like, oh, I accidentally plugged in 25 instead of 28, or when I wasn't watching and I only got the 2 in there. And so then you'll end up with the wrong answer. But if you are careful and plug everything in your calculator properly, it will treat you well, and you'll get the answer that you need. But if I'm finding the angle, again, it's a little bit more work. And in fact, when we're finding the angle, we have to pull out some algebra. So we're kind of going to be doing what we did at the end of last chapter and what we've done before, where I'm going to be solving a trig equation. I'm just going to be using my calculator to do it. Okay? So I'm going to start the same way, draw my picture. F, D, E, across from F is side F, across from E is side E, and across from D is side D. And they want me to find angle E. The angle that I'm finding is important to know. And if I can find any angle, I have to pick an angle in order for me to set this up properly. It's important that you're careful about where you're putting your information. Because I'm finding angle E, side E is the one that has to go on the left-hand side all by itself. I can't just randomly put any side that I want. I can randomly put the next ones in any order that I want to. But the side, oh, how'd that happen? But the side is, the side opposite the angle I'm looking for is the one they have to be farthest apart, okay? So I can do now 27 squared plus 19 squared minus 2 times 27 times 19 times the cosine of E. Now I'm going to square off this E. I'm blocking it. Yes. Oh, thank you. Thank you. Thank you. Let me fix that. 12 not 19. I already used 19. Thank you for that catch. So 12 and 12. All right, so I'm going to block off the e, the cosine of e. That's going to be the variable I'm going to solve for. In fact, I'm going to call it x. And then I'll deal with it in the end. I want this to look as much like algebra as possible. So I'll figure out what 19 squared is. This one I have to do in pieces. I'll figure out what 27 squared plus 12 squared is. And I got 873. And then I'll figure out what negative 2 times 27 times 12 is. And that's negative 648 times x. Treat this like an algebra problem. When you are solving, you have to work backwards. You cannot subtract these two first. It's not an option. And you are guaranteed the wrong answer if you do. I have to solve this like an algebra equation, meaning I have to get rid of that 873. And then get the x alone by dividing the 648 or the negative 648 out. So I did this before when we were solving in our last chapter. I said, okay, I put that x in there, and I got a value for x. But remember, I'm not solving for x. What am I solving for? I'm solving for the cosine of e. So that means that the cosine of e is equal to 0.79012, blah, 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 more goes after that. So to find e, I have to do the inverse cosine. And this is where that answer key, yes? Nope, because it's minus, stay there, come on. Oh, I don't even know where that went anymore. Okay. I don't even know how, okay. So I know I said negative 2 times whatever, because I was just choosing or treating that as plus negative. So then it would be plus negative 648 or minus 648. What's that? Is it? I think I might have. I think I might have dropped it off now by hitting it with my thank you for the elbow idea. That's just so bizarre. Like that sheet opens up, whatever. Anyways, I'll just rewrite that and we'll pretend like that never happened. Cosine E equals 0.79012. So now I'm going to do the cosine inverse of that answer. And again, that's where my answer key comes in really handy because I have that ugly decimal that I don't want to write it down and I don't want to round it. So I just do second cosine, second answer, and I get 37.8. 0.8 degrees. So that's an area of where I see a lot of errors. Okay, a lot of times people forget that you have to do the algebra part there. So please, I try to warn you on the little things that could happen and cause troubles. Star number 7 and write yourself a note. You have to do algebra when you are solving for an angle on the law of cosines. Actually, always when you're solving, but it shows up on the law of cosines a lot. Now the last problem is going to also pose another situation or bring us another scenario that could happen. If we start to draw our last triangle, our last example here, QRP, angle Q, angle R, angle P. I start to fill in my information. Across from P is 21, across from R is 8. Angle Q is 113, and they want me to solve angle R. Well, I don't have a complete ratio with P that allows me to do the law of sines because I would have a missing angle, two missing angles. I don't have a complete ratio with Q to do the law of sines because I'm missing that side. And so what that means is I'm going to have to find something before I can find the actual answer. And this will happen often where they want you to find something, but you're missing another piece in between. And so I'm going to start by finding side Q. And sometimes you're going to have to think in advance what's going to benefit me the most. Or sometimes it's going to be a scenario like, what can I do? Like, what's the only option? Well, the only thing I can do here is find side Q. And once I find side Q, then I can figure out what to do to find angle R. And your choices are endless. Like I said, always try the law of sines first. If that doesn't work, then go to the law of cosines. Well, this one's set up where all I can do to find side Q is the law of cosines. So I'll do the Q squared equals 8 squared plus 21 squared minus 2 times 8 times 21 times the cosine of 113. And again, I'll just plug that in my calculator and get the value. When I plugged in my value, that whole thing, I just plugged that whole thing in my calculator. I got 636.2856. There's more decimals. And again, it depends on the calculator that you have, how many decimals it shows. So to find Q, I'm going to do the square root of that answer. So second square root of that answer that was just plugged in there. And I got 25.2-ish. This is a rough season about 25.2. So Q is about 25.2. So I'll plug that in there. And I still haven't done what I need to do. I still need to find angle R. Now, to keep it consistent with this page, I am going to do the law of cosines to find angle R, just because this is the law of cosines page. But if you were doing your work on your own, you would probably, hopefully, recognize that you could set up the law of sines at this point. Because you have 113 over 25.2, or the sine of 113 over 25.2 would be the sine of R over 8. So you could do the law of sines. But again, to keep it consistent on the law of cosines page, I'm going to do the law of cosines and run through that to get extra practice on it. So I'm going to change my color. And we'll set this up to find angle R. Because I'm finding angle R, I will put the side across from angle R in the answer position. So 8 squared is equal to 25.2 squared plus 21 squared minus 2 times, try that again, minus 2 times 25.2 times 21 times the cosine of 113, because that is the angle across from 8, so it's in the farthest spot possible. Now I'm just going to start doing my math. 64, remember, these are the ones you have to do in pieces, and then I can solve for, I know what you guys are thinking. I can almost hear you yelling at me through your masks. What did I do wrong? What should I have there? R, thank you. Okay, so we'll put that R in. All right. The errors I make. I apologize. I never pretended to be perfect. Anyways, so we have 64. We have 25.2 squared plus 21 squared. I'm going to get that piece. So for that, I got 1076.04. And then minus, then I'll do the 2 times the 25.2 times the 21. And for that, I got 1058.4. And then remember what I said. What we're solving for is that cosine of r. We're trying to figure out what the cosine of r is so we can find r. And so I'm going to put that in as my variable x right now, just to keep myself in algebra mode. Once you get better at this, you might find that you don't need to do that. And that's fine if you're there. So I'll do 64 minus the 1076.04 to get negative 1012.04 equals negative 1058.4x. So I just subtracted the 1076.04. Now I'll divide. So the negative 1012.04 divided by negative 1058.4. And I get an ugly decimal. So 0.95619 blah, blah, blah is x. But I'm not solving for x. I'm solving for the cosine of r. So now I'll do the cosine inverse of that answer to get r. So second cosine, insert the answer, and I got r to be 17.0 degrees. I always try to check for reasonableness in my answers when I'm working through these, and so I recommend that you do too, because remember, when you are working with triangles, the biggest angle should be across from the largest side, and the smallest angle should be across from the smallest side. So it makes sense that a little angle will open up to a short piece where a big angle would open up to a longer piece. Hopefully that makes a little sense. And it does look very reasonable. 17 degrees opens up to 8. 113 opens up to 25.2. So always take a few moments just to check for reasonableness. So what you need to work on now is your homework 5-1, evens or odds, just like usual. And then when we meet again, or actually on your virtual, you're going to take this one step further and you're going to be solving triangles. So you're going to be finding all of the missing pieces. And in fact, your homework on your virtual is going to be a little bit different, because I'm going to run through 2 problems on the notes sheet. And then your homework is just going to be to finish the last problems. I think there's 6 of them on the notes sheet. So you're not going to be working out of your homework packet in your virtual tomorrow, all right? Or whatever, when you are virtual next. And then when we meet again, we're going to discuss some problems that can happen when we're solving for triangles. You're not going to have any problems on the triangles that you're working on your own, but we'll see some things that can happen when we meet again. So that's kind of, again, our plan. I hope you guys ask if you have questions. Okay. And